Hey everyone, this is the answers to the 1 through 3 for test review. So I'm going to go through each of these questions here and just walk through how you would solve each one. So for question number 1 and 2, you are using this equation right here. Okay, so we first need to find the degree and the leading coefficient. So in order to do that, we have to put it in standard form, which just means that we have to do the largest exponent first. So 6 is my largest exponent, so I'm going to put that first. And remember, whatever the sign is in front also comes with that term. So I've got 3x to the 6th, then negative 2x to the 5th is next. And I'm going to cross them out as I go to make sure that I got everything. Then the next biggest exponent is going to be 3x squared, then plus 2x, and then minus 6. And now once it's in that standard form, we can find the leading coefficient and degree by just looking at this first term. So our degree is always the exponent, so that's going to be 6. And then our leading coefficient is going to be the number in front, and that is a 3. Okay, so make sure the sign has to come with that too. So if it was a -3, your leading coefficient would also be -3. So again, leading coefficient, just the number in front, do not put the variable with it. And then the degree is always the largest exponent there. And then now for the end behavior, we have to figure out, this is our even, odd, positive, or negative. So remember, the positive negative part comes from the leading coefficient. So ours is positive. And then the degree tells us even or odd. So this is a positive even function, which means it's going to look something like a parabola opening up. And then every time that we write our end behavior, it's always as x goes towards infinity, y goes towards something, and we're going to fill that in. And then we also have a second one, as x goes towards negative infinity, y goes towards something. So remember, this is just telling you directions. So as x goes towards infinity is the right-hand side over here. So as we go towards infinity, as we go towards right, the y value also goes up. So that's going to be a positive infinity. And then for the left-hand side, we are also going up. So that's going to be positive infinity there too. Okay, so if it was going down, it would be negative infinity. But based on that picture right there that we drew for ourselves, because it's positive even, both of my y values are going up at the ends. So as I go right, I go up. As I go left, I go up. Okay, for question number 3, we're finding the relative maximums and minimums. So again, you are just naming these points. So there, and there. So for those, a maximum is a high point. So that's going to be this one in the middle here. And the value for that is just 0, 4. For our relative minimums, those are our low points. So it's going to be these two right here. And then the first point is -1, 3. And the second is 1, 3. Okay, so you are literally just naming those points. Any of the high points are the maximums. Any of the low points are going to be the minimums there. Okay. So over here for the matching, it's going to be a little hard to see all of it, but I'll scroll down. So for question number 4, we are just looking at end behaviors here. So you're looking at, first, make sure that they are all in standard form. These are, so I can just look at that first term. This one is negative even, so it's going to look something like a parabola opening down. So now once I figured that out, I can just look at these choices and look for the one that looks similar to a parabola opening down, and that's going to be D. So for question number 4, because it's a negative even function, it is going to look like a parabola opening down. So that's going to be answer D. For number 5 here, we have a positive odd function. That's going to look like our squiggle going up. So we're going to scroll down, look for that squiggle going up, and that one's going to be C, because this is a squiggle that goes up. Okay, so number 5 is going to be C. For number 6, this is positive even. And just like we did on the question on the other side there, it should look similar to a parabola opening up. So that's going to be A, because again, the middle parts don't matter as much. We're just looking for what's happening at the ends, because even though it has like this little blip right here, that doesn't matter because we're just looking at the end behavior. And then 7 has to be B, and this is a negative odd function, which means it's going to be a squiggle going down, which is letter B. So again, just like with your end behavior, you're looking at, is it positive or negative, even or odd? The positive negative comes from the leading coefficient, what's in front of the variable. Your even or odd comes from your degree, which is your biggest exponent. And then you're just matching the shapes for this one. Okay, so onto the back side. Okay, number 8 is just asking us to add these together. So remember, when we're adding two polynomials together, you are just combining your like terms. And you always want to write it in standard form. You have to put your biggest exponent first. So I can combine the two x cubed functions or x cubed terms. So I get negative x cubed because I have 7 minus 8. Then I have an x squared term. That doesn't have anything to combine with, so I just rewrite it. Then I have my x's, those cancel each other out, so I don't have to write it. And then I have the minus 9 at the end there. Okay, so again, you're just combining like terms, just add them together. And then make sure that your final answer is in standard form. For question number 9, we're subtracting here. And remember, whenever you subtract, you have to change all of your signs to the right. And then once I've changed those signs, I can do the exact same thing that I did with number 8, where I'm just combining my like terms. So I've got 2x to the 4th, and that doesn't have anything to combine with, so I'm just going to rewrite it. Then I have my x cubed terms, and I combine those. I've got negative 5 plus 1 gives me negative 4x cubed. Then I have an x squared term over here that doesn't have anything to combine with, so I've got negative 7x squared. And then I have my x term over here, and that doesn't have anything to combine with, so I just rewrite it. And then also with the 3 at the end. So not a lot of combining here for us to do, but you're just rewriting it in standard form, making sure that all of your signs are correct. So guys, a lot of this math here, again, it's not super hard for us to do, but we have to make sure that we're very, very careful when we are adding, subtracting, multiplying, and dividing, because one little mistake can cause a lot of issues for us. Okay, so that's number 9, that's subtraction. Number 10 is worded a little strange, but all this is asking you to do is take function h and subtract function g. So if you want to rewrite this out, it's 3x cubed plus 2x squared minus 3x plus 5, that's h. And then I'm subtracting g, which is negative 2x cubed minus 8x minus 6. And then I can do exactly what I did before, change all my signs. Those are all going to be pluses now. And then I just combine my like terms. X cubed with x cubed, 5x cubed, x squared by itself, x's together, I get 5. And then the 5 plus the 6 gives me 11. So there's my final answer right there. Okay, so again, guys, anytime that you see something that's got like a lot of words to it, just look at what they're actually trying to have you find. So it's just asking you to do function h minus function g. They just didn't write it out for you. Number 11 is find the product. And remember, product just means multiplication. When we multiply, we have to distribute everything to everything else. So I have to take that x and multiply it by everything. So I get x cubed minus 3x squared minus 5x. Then I do the same thing with the negative 4. So negative 4 times x squared is negative 4x squared plus 12x plus 20. And then remember, once you multiply, you have to combine your like terms again. So I've got x squareds, I've got x's, I'm going to combine those. So I've got x cubed minus 7x squared plus 7x plus 20. And there's my final answer right there. Okay. For number 12, this is a division problem. So again, this one is worded a little strange. We haven't necessarily seen it like this. The reason that they put the x cannot equal 7 is if I plugged in a 7 on the bottom, I would get 0, and I'm not allowed to divide by 0. So that doesn't affect what you're doing at all. They just have to put it there, or else you're technically not allowed to solve the problem. So that's the only reason that it says x cannot equal 7, is because they have to put it there or you're technically not allowed to solve it. So when we go to solve this problem, you can use long division here or you can use synthetic division. I know that a lot of you guys like synthetic division better, so we'll do it that way. So remember, in the box in the corner, it's always your solution to what you're dividing to, which just means I'm flipping the sign on that. So since it was x minus 7, I then am going to put a 7 in the box. Then up top next to the 7, I just put my coefficients. So first we have to make sure it's in standard form. Then we have to make sure that we're not missing any terms, and we are good. So we're just going to write out our numbers. So I've got 1, negative 13, 48, and negative 42. So my first step is always I'm going to drop down the 1. Then I multiply whatever is underneath here by the box. So 1 times 7 gives me 7. Okay. And then you're just adding those together straight down. So negative 13 plus 7 gives me negative 6. Negative 6 times 7 gives me negative 42. Then I get 6. And then 6 times 7 is 42, and I get 0. Okay. So now, once I did all the math here, we have to turn it back into a polynomial. So remember, on the right, you always start with the remainder. Then it's your constant term, and then x squared. And if there was another term, you just keep going up with your exponents there. So the next term would be x cubed, then x to the 4th, but we're good here. So anytime you have a 0, remember, you don't have to write that, but it still is a placeholder there. So my final answer here is just going to be x squared minus 6x plus 6. There is my final answer. I don't need to write my remainder because I don't have one. Okay. So that is our synthetic division. If you want to do it with long division, you can do it with long division. I know just a lot of you guys prefer to do it with synthetic. So that's why I wanted to show you the synthetic. All right, on the right-hand side at the top, we've got one more division problem. And again, you can do this with synthetic because it is just a single x there. It's not like 2x. So as long as there is a single x there, you can solve it that way. You can do synthetic. And again, I'm not missing any terms here, so I just rewrite them up at the top. And guys, again, I just want to stress the importance of taking your time with this and paying attention to what you're doing. Because a lot of this, like, again, the math is not hard. It's just you need to make sure that you aren't making any mistakes in your math, because then it'll screw up everything. I get negative 7. Okay, so again, start at the right, remainder, constant, x squared. Okay, so now when I rewrite it, x squared plus 6x plus 6, and then remember your remainder is always a fraction, and it's always dividing by what you divided by. So it's minus 7 over x minus 8 there. Okay, and again, you can do long division, but synthetic is a lot easier and faster. So I would suggest using that one. Okay, unless you really like long division, then you can do that. For number 14 through 17, we are factoring these. And whenever we factor, make sure that you are actually finished and it's completely factored once you get to the end. So for number 14, these are perfect squares, which means, again, like all of these they're either perfect squares or perfect cubes. And we need to make sure that when we are solving these, you're doing the right one. So this is a perfect square because it's got a square, and 49 and 4 are both perfect squares. So when we do our perfect squares, you take a square root of each term. So I've got 7x and 2. For perfect squares, it is just the exact same thing, but one is a plus and one is a minus, and we're done with number 14. That's it. Just, you have to remember that. So I take a square root of both of my terms. The square root of 49x squared is 7. The square root of 4 is 2. One's a plus, one's a minus. Done. And it doesn't matter which way you write it. If you wrote 7x plus 2 first and then 7x minus 2 second, that's totally fine. Because it's the same answer there. Okay. For number 15, I see a squared for my x, but 2 and 18 are not perfect squares. So that tells me I have to take out a GCF first. So I'm going to take out 2 from each of those. And then I've got x squared minus 9. Okay, and this is what I was talking about. When you have factored it, you have to make sure that you are totally done. Once you take out a GCF, check to see, can I still factor that? Yeah, those are both perfect squares. So I'm going to factor it the same way I did for number 14. I'm going to take a square root of x and a square root of 9, and I get x and I get 3. And then my second is x plus 3, because that's how we factor perfect squares. And this is our final answer. So if you stop here, that is not right, because that's not fully factored. Okay, you need to make sure that you factor it all the way. Okay, now looking at number 16, this is a perfect cube because we see a cube up in the top. So now for this one, we take a cube root of each, which is going to give me 3x and a 2. And remember, kind of similar to our perfect squares, we are going to take a cube root of each one, but then to find our next terms, remember we square this first term. So I get 9x squared. Oops. For my middle term, I'm multiplying them together. Excuse me. So 3x times 2 is going to give us 6x. And then for the last term, I'm squaring that 2, which gives me 4. And then to remember my signs, we use SOAP, which means same, opposite, always positive. So it's the same as this, which is a positive, and then it's opposite, which is a negative, and then the last term is always positive. So there is my final answer. So again, guys, not a lot of like work to do here. It's just we have to remember the process. Okay, and last one that we're going to go over is x cubed minus 64. So same thing, perfect cube, take a cube root first. So that's going to be x and 4. First term, I'm squaring x, so I get x squared. Middle term, I multiply them together, I get 4x. Last term, I square the 4, which is 16. Same, opposite, always positive. Okay, so again, guys, I just want to stress, your math here is very, very important. You need to pay attention to what you're doing. You need to make sure that you are checking your work once you're finished, because if you forgot a negative sign somewhere or you multiplied something by 2 instead of squaring it, like those little mistakes are going to cause big problems. Okay, so I just want to make sure, like, I know that you guys can do this. You guys have been doing really, really well with it. Just please, please, please be super careful on your test. Make sure that you are paying attention. Make sure that you are checking your work. Okay, so that is it for the review.